Hello, assalamu alaikum.
Salam.
So,
Rahman.
how are you?
I'm doing great. What about you?
Alhamdulillah, I'm fine. Thank you. So, basically, yesterday I also busy with some other tasks, so that's why I will not send you the previous video recorded class. So today, I also send you the both of two video recorded classes. So you also practice in the middle time, and then we also continue from our next Saturday. Okay. So let's go. Okay. So I simply share my recorded this video class. So now can you see my screen? Yeah.
Yes.
Okay. So we will start our today's class. Okay. So let's. Okay. So hi and welcome the 7 days online training program on Google Earth Engine or remote sensing analysis using Google Earth Engine. Okay. So basically, I am course coordinator and it's our full course content total 7 days. We try to complete it all of the course module within the 7 days. Okay. So let's go. And today is our third day. And basically today I will talk about that our third sports content will be that. I will try to discuss about the filtering and displaying the satellite image Sentinel-2, okay, and monitoring the NDWI or normalized difference water index, okay. So basically, we previous day we also try to discuss about the Landsat image, but in this time we also try to talk about the Sentinel-2 satellite imagery. Okay, so Sentinel-2 satellite imagery, we can filtering and displaying, as well as we also try to calculate the NDWI or normalized difference water index. Okay, then we also try to discuss about the NDVI time series chart. So how we can easily make the time NDVI time series chart using the Landsat imagery. We also try to discuss about that, as well as how we can easily export any shape file and make the map layout. Okay, so previous class we also try to discuss about that NDVI map, but I did not show you that how you can easily export this map and make the map layout using ArcMap software or QGIS software. I did not show you this process. Okay, so in this time I also try to show you this process how you can easily export this as a raster image or as a shape file. How you can easily export this, and then you can simply make the map layout. Okay, then we also try to discuss about the LST monitoring, so land surface temperature monitoring. What is the condition of the LST? We also try to discuss about that, and we also try to make the LST monitoring time series chart. Okay, so how we can easily make the temporal analysis of the LST using the time series chart. We also try to discuss about that, and we also try to discuss about that NDWI calculated from MODIS and Landsat data. Okay, so let's go our today's class. I will try to follow step by step, then discuss one by one topic. So let's go. So first of all, filtering and visualizing the satellite images in Google Earth Engine platform. Previous class, I also try to discuss about the three factor. First factor is that region. Okay, region. Suppose you want to need the Landsat image or Sentinel image for a region. It can be Dhaka city shapefile or it can be your own research area shapefile. Okay, so you can simply import your shapefile and then you can simply work with the shapefile. Okay, and then we also filter the image specific metadata or image specific properties. Suppose you want to need the image which image is only less than 1% cloud cover. You want to need only for this image which image will be not more than 1% cloud cover. So this is the one kind of image properties or image metadata. So we also try to discuss about that how you can easily filtering the image metadata, and then we also try to discuss about that another factor. Suppose any specific time period, suppose the dry season, rainy season, winter season, or any types of season, how you can easily get these satellite images. Okay, so let's go over today's class. So I simply open my code editor and then I simply open a new code editor. I simply open this. So I simply go to the browser. So I simply open a new browser, new code editor, and then I simply go to my code editor. So this is my code editor. I simply open my code editor. In this time, I want to work with the Sentinel-2 satellite imagery. Okay, so I just simply browse data catalog. I simply click on the browse. I simply click the browse data catalog and find out the Sentinel-2 satellite imagery. And I filtered this, as well as I also calculated the NDWI, normalized difference water index. What is the condition of the NDWI? I also try to discuss about that. Okay, so let's go. I simply click on the Sentinel. You can see Sentinel. I click on the Sentinel. I want to work with the Sentinel-2 multispectral instrument. This image collection I want to. In this time here you can get the two types of Sentinel-2 satellite imagery: top of atmospheric reflectance and surface reflectance. Okay, I try to show you the top of atmospheric, but you also try to surface reflectance. Okay, the both of things will be same. Some difference in the image properties, as well as also some difference in the image band. Okay, so in this time I simply click on the top of atmospheric reflectance satellite image. So here I can get all of the information about the satellite image. Here you can see this is the multi-spectral instrument level 1C. Here you can see dataset availability date. It will be start from the 2015 06/23, from 2020 10/15. We can get the dataset between this time period. As well as also you can see this dataset provided is the European Union Copernicus. Okay, this dataset provider. As well as also you can see the Earth in this snippet. This is the unique ID of this dataset. Okay, so this is the one. You can simply copy this and paste in the code editor. It's also okay. Or if you can also search here the dataset. Suppose I need the Sentinel-2, so I simply search here Sentinel-2. Okay. You can see I can get all of the. I want to work with the multi-spectral instrument. Okay, so simply click to here. Here I can get all of the same information. Also here you can see all of the description about this dataset. All of the band. Okay, with their resolution. Okay, I can easily get. Also I can get the image properties, different types of image properties for this dataset. So I can simply click on the import. You can say simply click on the import. Now this dataset is imported in my code editor, and now I can easily work with this dataset. So in this time, I just simply put a variable name in here. So I simply put the variable, suppose Sentinel-2. You can use any name, no problem. In this time, suppose I want to need this Sentinel-2 satellite imagery for my region of Dhaka city. So I simply import the Dhaka city shape file. Click where it will be imported, and I put the name is that, suppose ROI. Okay. In this time, suppose I need the Sentinel-2 satellite imagery for 2 period of time. I need the Sentinel-2 satellite imagery as a dry season, as well as also wet season or rainy season. So 2 time period of satellite image I want to need. So I want to need the filter the 2 time. First time I need the satellite image for the dry season, and second time I also need the satellite image for the wet season or rainy season. Okay, so I simply take a variable. Suppose I put the variable name is that image dry. Okay, so I simply store in this variable dry season satellite image. Okay, I simply call the whole full collection. Okay, simply call and paste here. In this time I use here the filter bounds function. So I use here the filter bounds function because I want to intersecting with my full collection with my region of interest with ROI. You can see what is the argument. You can say I can get the argument is the geometry. So mainly geometry is that ROI. I simply put here the ROI. In this time you can see what happened. In this time Sentinel-2, this is my full collection of Sentinel-2 satellite image collection, and I want to use the filter bounds function. So in this time, from the full collection, I get only for this region collection. Okay, ROI. So which image are available in this time in my shapefile, I get only for this image, and it is stored in this variable. Okay, so in this time, suppose I simply use here the dot notation, and then I simply put here the another function for filter date. Suppose I simply use here the filter date function, and then I put my specific time period. In this time, I want to need the satellite image for the dry season. Suppose I need the satellite image for the dry season of year of 2020. 2020 dry season image I want to need. So I simply use here the start date 2020, then 1st January, and put the end date will be that. I simply put here the 2020, then use here the April 04 and suppose 30. So according to the Bangladesh region, this is the time period is for dry season time period. Okay, and then I can simply use here the filter metadata. Okay, in this time I can simply put here the image properties name. So what is the image properties name? You can see I can easily get the image properties name is the cloud pixel percentage. I simply copy and paste here. I simply use here the cloud pixel percentage. I use here the operator. Operator is the less than. I simply put here the suppose less than, and I use here the value suppose 1. Okay, so I want to check how many image is available. So I simply print this, and then simply call the image dry, and paste here and click to the use here the size function. You can see in this time you can get, okay, so this size function I need to use here the parenthesis and click to the run. So now I can get how many images is available for my region between this time period, which image is the less than 1%, 1 cloud pixel percentage. We can find out total 20 images. Total 20 images I can find. So this is the one you can, if you can simply use the filter metadata function, you can get the 20 images. Okay, this is the one way for filtering the image properties. Another way is that you can easily use here the sort function instead of the filter metadata function. If you want, you can also use here the sort function. So you can simply use here the sort function. You can sort according to the cloud pixel percentage. I simply copy and paste here. Okay, and then I simply use here the, I want to check how many images I want to get. So I simply click to the run. In this time you can see according to the sort function, I simply sorting the cloud pixel percentage. These properties I want to sorting between this time period. I want to get 48 images. Okay, in this time I can get a lot of images. Okay, this according to the cloud pixel percentage properties. I can simply use a function. It's called the false function and click to the run. You can see I can get the same images. In this time, when I use the false function, it remove all of the cloudy pixel from the 48 images. It will be remove all of the cloudy pixel. Okay. In this time, if you want, you can simply use the median collection. Median. So when you want to use the median, then from the 48 images, it calculated their median pixel value and make the one composite. Okay. Or if you want, you can use here the another function. It's called the mosaic function. So mosaic, the mosaic function. So mainly mosaic, this is a function. We are using this function for composite all of the images and make a one composite. You can simply search here the mosaic function. Then you can get the details about the mosaic function. You can see. I simply search the docs tab. You can see mosaic. So mainly, what is the mosaic? Composites all the images in a collection using the mark. Okay. So in this time, when here I can get total 48 images. So 48 images in a collection. Okay. I want to show the result in this time. So I simply use here the layer. So I simply use here the map dot add layer, and then I simply call the image dry. I simply copy and paste here and the run. You can see I can get the layer, but I did not see my region. So in this time, I need to focus the center of the shapefile. I simply use the map dot center object, and then I simply call the ROI and use here the suppose 10 and click to the run. So now you can say I can get this satellite images as a full area. Okay, in this time I get the satellite image as a full area. In this time I also need to add here the another function. It's called the clip function. I simply use here the clip function. Clip with my shapefile. My shapefile is that ROI, and click the run. So now you can see I can get the result only for the country, Dhaka city country boundary shapefile. You can say I can get the result, but this result is not good. I can see here the totally black color image. Okay, in this time I need to add here the band combination. So I can easily use here the different types of band combination. So for this I simply click to here, you can see, and then I simply add here the suppose red band, then also use here the green band, and also use here the blue band, and also increase the stress 98% for better looking and apply. So now you can see this visualization is added in this code. You can see I can get very good quality of images in the dry season of Dhaka city. You can see in this time I just simply import. You can see click to the import. A new line of code will be added here. I simply copy the variable name and just simply paste after the object name. This is my object. Then I need to put here the visualization variable name. So I simply put here the visualization variable name and put a layer name. Suppose I put the layer name is the dry image. Okay. So now you can see it will be set. It just said, you can see dry image. It's set in here. Okay. I can get the dry season image of Dhaka city in here. Okay. In this time, I also need for the wet season satellite image or rainy season satellite image. So for this, I can just simply copy the same code. I simply copy the same code from here. Simply copy the same code and paste in here. And paste it. I just simply change the variable name. Suppose this is the image wet season. And then I simply put here the wet season time period. Suppose, so mainly perspective in Bangladesh, this wet season will be start from the June, 1st June, and up to the October. So I simply put here the October. Okay. So October, suppose October 31. Okay. I simply change the time period. And then all of the things will be same. I simply copy this object name and paste here. And I simply change, this is the wet image or wet season image. And click to the run. In this time you can see the another image also added, and this image another layer is also added. So this it will be represented the wet season image. So you can see this is very easy. We are using only for the one code, but we are easily remove. We using the same code, just we need to change the time. Okay, then we can easily get the another period of satellite images. So you can see we can get the two layer of satellite images in here. In this time you can see very interesting part is that you can see when I want to see the dry season image, there is the no cloud. But when I want to see the rainy season image, so here I can find out the some cloud. You can see this is the cloud. Okay, this is the cloud. You can see this is the cloud. You can see this dry season image. There is the no cloud in the this. It's very clear satellite image. But when I open the wet season image, you can see here I find out the some cloud. Okay, you can see there is a lot of cloud in here in this region. But Google Earth Engine has a some feature or has a some tool or has a some function. So when you are using this tool or function, you are easily removing all of the cloud and haze from your satellite images. Okay, you can see this satellite image is not so good, and this satellite image is not perfect for making the land use and land cover classification map. Because when you want to make the land use and land cover classification map using the satellite images, in this time this cloud pixel value will mixing with build up area or barren land area. It will be, this pixel value will be mixing. Okay, and our accuracy is not so good. Okay, when you can use this image. So that's why we also need to removing the cloud from the satellite images, and we also need to the clear condition of the satellite images in the wet season or rainy season. Okay, so I also try to show you this part our next class, how you can easily remove the cloud from the satellite images. So in this time you can see I can get the two period of satellite images, wet season and dry season. You must be get the cloud in the wet season or dry season image. You can find out the cloud, but you can see dry season there is the no cloud. Very clear satellite image we can get. In this time, using the both of two satellite images, I want to calculate the NDWI or normalized difference water index. What is the condition of the water on the surface of Dhaka city between the two time period, dry season and wet season? I want to calculate this and also visualize this map in here. Okay, so let's go. Okay. So mainly when you want to calculate the NDWI, we need to two band. We have need to two band. So we need one band for the green band and near infrared band. Okay, we need a green band and near infrared band. Okay. So for this, I just simply use a two band. So our formula is that NDWI, and this formula is that green band minus near infrared band divided by green band plus near infrared band. Okay, so I can simply use the NDWI formula, green minus near, green plus near. So this is our formula. And previous class I also tried to show you a one method for calculating the indices for the, I think it will be NDVI. So near infrared band minus Z band plus near infrared band plus Z band. Okay, so this is the one method. I also try to show you that. In this time I also try to show you the another method. This method, it's called the normalized difference built-in function. You can see normalized difference built-in function. So I simply start the function normalize. You can see normalized difference function. So normalized difference function, this is the built-in function. Mainly this function compute the normalized difference between two bands. So when you are using this function calculated the normalized difference between two band, okay, green band and near infrared band in this time for NDWI, and it's the normalized difference is computed as, you can see, first minus second divided by first plus second. In this time, green minus near infrared divided by green plus near infrared. So when you are using this built-in function, it automatically calculates the equation. Okay. So in this time I use the function and calculated the normalized difference between the two bands, near infrared band and green band. So for this, I simply take a variable. Suppose this variable name is that NDWI for dry. Okay. First of all, I calculated the NDWI for dry season. So just I simply copy the dry season image. So this is my dry season image. I simply copy and paste here. Okay. And then I simply use here the function normalize.
It's just before you go ahead, if I can just share my screen because I have index here of working.
Yeah. Any question?
Yeah.
Yeah.
So my code, I have small error.
Okay. Sometimes it's buffering. I did not hear you properly. Yeah. Okay.
I just syntax
Yeah.
error, but I
Okay. So
was
in this
running
time,
because
it has a problem. You can see. So in this time, your code, you can see this code is showing the short. Okay. You did not print after using the mosaic function. You did not print this. It's not printed. In this time, you can see when I want to use there the mosaic function, it's make a one composite. You can simply remove the mosaic function and click to the print this, then it will be work. Okay, you can simply remove the mosaic function, and yeah, and also remove the filter bounds. You can also remove this. So you can simply use that the only for the filter bound. Okay, you can simply use that the filter bound.
so this is it.
Yeah, yeah. You can see you use that the e filter dot bounds. Okay, in this time, in this code, you can simply run this. Then check what problem. Simply run this again. Run the code again. It's showing the RGB. Okay, so these are the parameter you are using this band, B4, B3, max, min, max, and band. You are using this, and then you can simply, okay. So you are also remove this code also. RGB. You can also remove this code also. Yeah. Then click to the run.
But even I used it for, I did it last night and it works.
Okay, so in this time, okay,
If
okay,
I
so
show,
yeah,
I did it yesterday.
okay, so
Yeah, I did like it
yeah,
and it was working.
so you upload your shape file in here.
Yeah, I have just installed the
Okay, so simply upload your shape file from the asset tab. Yeah, yeah, okay. Then put the name. Also import the image collection. Okay, Sentinel. Put the variable name as a Sentinel. Yeah. Okay, so now it's work.
Yeah, if you want to
Yeah.
select
So here you can see we can get the total 689 images. Okay, 689 images. In this time, here okay. In this time, you can see you can get the image look like this because you did not use any mosaic function. You did not use here the mosaic function, as well as also did not use any median or mean. Okay, so in this time it's showing only for the image. If you can flip this and show the result. Okay, so in this time you also need to use here the mosaic function. So mosaic mainly it all of the images make a one collection. Okay, so simply use here the mosaic function and then
So if I look the mosaic, it will be working.
yeah mosaic yeah. Yeah, then in this time you can print is not work. So because you need to simply remove the print, and in this time print is not work. Yeah.
But just
Also remove the filter dot size. Okay. Also remove this. Yeah.
it's
Yeah.
not like that.
And click to the run. In this time you can see mosaic and median you did not use it at the same time. Okay, mosaic and median function you did not use it at the same time. So in this time you can also remove the this line var image equal to filter dot median. Also remove this. Also remove this because you are already using the app. Remove this. And after the mosaic you can simply use the clip function. Okay, after the mosaic you can see after the mosaic function simply use the clip function. And also remove this. Yeah, also remove this and then no. Okay.
You can use
Okay.
clip
Okay, no
also.
problem. Okay. No problem. You can in this yeah. In this time we can simply use the dot clip. Dot clip with your shapefile variable name. And then simply copy the filter rate, your variable name. Final object. Filtered. Not here, not here, not here. You can simply copy the filter rate variable name. Simply copy this name and write in the map.add layer after write the filter rate function. Filter rate variable. You can see var filter rate then sentinel. You can see the 4 number of line code. 4 number of line code. You can see the variable name. What is the variable name? You can see filtered. Okay. Yeah. Yeah. You need to use the same variable name also after use here the map.add layer. Okay. So it's okay. You can simply move to the map.add layer. You can simply move to the map.add layer function and remove the clip. You can see remove the clip variable.
This one will be filtered.
No. Clip. This right. Okay. There is a no problem. So clip with your shape file. You can simply put your shape file variable name. It's okay. You can write the shape file variable name. Okay, and then you want to show the display the result. Okay, in this time you can see all of the things is stored in a variable. This variable name is that filter it. Okay, so
Yeah.
you want to show the filter it. Okay, so simply you can, after the map.add layer, you write here the filter it, not clipped. Okay, you can see the map.add layer. You can see the map.add layer function. You can see the 20 number of port, 20 number of 20 line. You can see.
Yeah.
Yeah.
Okay.
You can simply remove the clip. You can see clipped. There is the no clip.
Okay. Okay. So we change it with MW.
You need to change the object name. Object name. Yeah. Okay. So this is a layer name. This is not important. The fast clip, you can see fast clipped. Before the RGB views, you can see the clip.
Yeah.
Yeah. Instead of the clip, you need to write here the filter it variable name, because your object is the filter it. Yeah. Yeah. Filter it, and also closing the quotation in here and click to the run. So now okay. So add this image. Okay, so now we can simply zoom. And you also add here the okay. I think you can also change the visualization from the edit layer properties. So simply go to the layer option. You can see layer. Yeah, and click here and change the visualization. Before it's okay, so you can simply click on the custom. Click on the custom and increase the 98%. Okay, then click to the apply. Okay. Okay, some tiles are overlapping. When are using the mosaic function, it's showing the some tiles are overlapping on this image. So you are using here the median function and try again. So instead of the mosaic function, you are using the median. You can see mosaic, instead of the mosaic, you can use here the median. Okay. Yeah, use here the median and then check the image. What is the condition? Yeah, and click the run. And this is the region for nearby the. Okay, so now this image is also key. Okay, so now you can see. Okay. Okay, so it looks like this because there the this region is not any types of spire or any types of area. It's a river. Okay, so that's why it looked like this, I think. Okay, so you can also send me this link. I also try to set up this in good images. You can simply click on the, first of all, you can simply go to your asset tab and share this shape file. You can see. You can simply click on the share file. Not here, asset tab. Simply go to the asset tab.
Asset tab.
Asset tab is the yeah, asset tab. And what is the shapefile name? Shapefile name. You can find out the shapefile in here. Yeah. Then simply click share. Yeah, share. Then click on the anyone can read. Anyone can read and done. Click to the done. Anyone can read. You can see. And it's not needed to change, so it's okay. And then done. And then you can simply click on the get link button and share this button with me.